Now we're going to prove one of the fundamental properties of the operator Laplace transform. So we assume that we have two functions, f1 and f2, and we assume that their Laplace transforms exists. In this case, we want to prove that the Laplace transform of their combination is the combination of the Laplace transform. We will need this one when we have some equation, differential equations like this. Y second plus y prime is equal to some sine t e to t. Okay, and we want to solve this equation. Here we can take the Laplace transform of these two, and we can take them after that one by one. So we can take Laplace of y second, and after that Laplace of y prime. And this one, this is a product. We're gonna talk about that one later. Okay, so this explains why we need this one. And to prove this result here, we assume that C Laplace of f1 is the integral between 0 and infinity of c1 e minus st f1 t dt. This one exists for some s bigger than s1. And c2 Laplace f2 is the integral between 0 and infinity of c2 e to minus st f2 dt. This one exists for some s bigger than s2. And we see that if we add these two, c1 Laplace of f1 plus c2 Laplace of f2, we get this integral of e to minus st c1 f1 plus c2 f2 dt by taking s bigger than both s1 and s2. Okay, and this means that this one here is just the Laplace of c1 f1 plus c2 f2. Okay, and this means that we can talk about linearity. Okay, this proves that when we're dealing with differential equations like this, as I said earlier, y second or y prime plus y equal to some e to t. Okay, so we can take the Laplace of y prime plus y and Laplace of et. We know this one, and we can here linearize. We can take Laplace of y prime plus Laplace of y is equal to Laplace of et. So here, this is why we need this result here. Now we're gonna talk about this one here. So we don't know the Laplace of a derivative of a function. Okay, that's gonna be the aim next. And after that, we're gonna talk about Laplace of two functions, the product of the functions, so we can get all the results that we need to be able to solve a differential equation. So the aim of all these properties is to be able to solve a differential equation. Okay, next we're gonna prove results like this. So we have Laplace of some derivative. Okay, some function that's the antiderivative of some function. What's that in terms of the Laplace of the other derivatives? Okay, we will see that, and we're gonna use it in some equations like this. Thank you.